In this last lesson of our chapter, we're taking all this area stuff that we've been dealing with, and we're also looking at some segment stuff that we've dealt with long, long ago, and we're using it to calculate probability. Now, I don't have it on my screen presentation, but you have it in your notes that you've seen probability before, gentlemen and ladies. Remember, for example, if I'm talking about the simplest kind of probability ever, the probability when we're talking about rolling the die. What's the probability of rolling a 1? 1/6. The reason why it's 1/6 is because there's only one 1 on the die, and there's 6 sides on the die. So you'll notice that in your notes you have the definition for probability. It's the number of favorable outcomes over the number of desired outcomes. And then you see a couple of translations of that into geometry. If I'm looking at a segment and I'm trying to find the probability that a point will be on a part of that segment, then it's the desired segment over the whole segment. Same idea with area. If I'm looking at a region and I'm trying to find the probability that a random point will be in that region, then it's the desired region over the whole thing. Okay, so we're starting simple. In problem 1, I have point P somewhere on Fj. I'm trying to find the probability that the point P is on GH. So what you're doing is finding the length of GH and putting it over the length of Fj. So what is the length of GH? It's 5. And then what's the length of Fj? 11. It's just that easy. In the your turn for it, there was an intended kind of problem that I wanted to address, so please fix the typo. Yes, sir.
But FJ is in 4 possibilities.
You're talking about the length of the segment. There's infinite possibilities. It could be halfway between two things. Okay? But we're talking about the length of these segments with relation to each other. Very good. I missed it. Sorry. Okay, so please fix the typo for the your turn. And when we fix that typo, some of you are looking at it kind of like, what? Huh? And that's kind of where I'm going with this. So a point S is on HJ, and it is selected at random. What is the probability that S lies on segment FJ? What is the probability that it's going to land on FJ if I know that it's on HJ? You're looking at it kind of cross-eyed, and that's kind of the desired effect. If it's on segment HJ, isn't it a certainty that it's going to land somewhere on FJ? Isn't it like a guarantee? If it's on HJ, it's definitely on FJ, right? When something is certain, its probability is 1. So maybe jot a note to yourself. The probability of a certain event is 1. Some of you like to think of probabilities along the lines of percents. The probability that this is going to happen is 100%. Okay, so since we're talking about one end of the probability spectrum, let's talk about the other end of the probability spectrum. If something is impossible, what is the probability of it happening? 0. Good. Okay, so realize the probability of a number will always be between 0 and 1. So now let's take this and apply it to a real-world situation. I have a river ferry running every 40 minutes, and a passenger arrives at a random time. I want to find the probability that he has to wait at least 25 minutes for the ferry. Some of you are thinking, well, how does this relate to geometry? Let's treat this like a timeline. So 5, 10, So the ferry runs every 40 minutes. So my timeline of 40 minutes indicates the time between those ferries arriving. So at 0, a ferry has just left, and at 40, a ferry is getting there. I'm trying to find the probability of having to wait at least 25 minutes. So let's talk about at what point on that timeline will a passenger wait exactly 25 minutes? At what point on that timeline will he be waiting exactly 25 minutes for the next ferry? At the 15. Okay? So that's exactly 25 minutes. I want at least 25 minutes. So there's a region of this number line that I'm shading. Am I shading the left side of the number line, or am I shading the right side of the number line? The left. Because if a passenger arrives anywhere in that red zone, he's waiting 25 minutes or more for the next ferry. Once again, realize 0, if a passenger arrives at 0, that's too late. Okay? So he's got to wait until the 40 minutes pass to get to the next one. A passenger is arriving at some time, random time, in this 40-minute span. If he arrives at this point, 25 minutes before the ferry arrives, he is waiting exactly 25 minutes. If he arrives any time before that, in this 40-minute window of time, he's waiting more than. So now it's just a matter of the desired region, whose length is 15, over the entire 40. And we reduce to 3/8. The your turn for this problem is a Centio question. If you haven't already logged in, please do so. When you find your answer, please enter it as a fraction. It should be on the lower right corner. There's still some of you not logged in. I know there's more than 18 of us in here. Oh, good listen. Okay, so no more than 5 minutes. Okay? So we first figure out what kind of time exactly. Good. So then we need to decide what side of this number are you shading. Now I want you to wait no more than 5 minutes. Okay, still waiting for a couple of you. Let's wrap this up, please. in the interest of time, I'll stop the question in 30 seconds. No one's going to be penalized if you didn't enter an answer. I just want to, keep things kind of moving on. Ten seconds. All right. And our overwhelming answer is our correct answer. It is 1/5. If you entered 4/5, I know exactly what you did. You shaded the wrong side of the timeline. Let's take a look at it. You would have a timeline of 25 minutes. So 5, 10, 15, 20, 25. The problem is asking us, what is the probability that a commuter will wait no more than 5 minutes? So remember our strategy. Let's find the point on this timeline where a commuter is waiting exactly 5 minutes. Where is that point on this timeline? At the 20. Now I want this commuter, according to the problem, to wait no more than 5 minutes. Does it make sense? No more than is the same as less than? Okay, so let's put it in English. If your teacher tells you to write a paper of no more than 500 words, are you going to turn in something with 1,000 words? No, you don't want more than. You want less than. Okay, so that's why this is the part of the timeline I'm interested in. What? Oh no! You're doing the length of this segment, not the coordinate of this point. It's the length of the segment, which is 5 over 25. Remember, it's the length of the segment, not the coordinate of the point. Be very careful. And that's what's beautiful about using the Centios and seeing these mistakes, is we clear up those misconceptions. Okay, we good on this screen? Fantastic. Okay, in problem 3, look at my problem 3, look at your problem 3. Please do to your problem 3 what I did to mine. And the reason is, first of all, 5 would be annoying, because I'd have to take that 5 and cut it in half to find the radius, and then I'd be squaring a decimal. Ew. And some of you are thinking, well, Mrs. Claus, can you just really change the number on a problem just because you feel like it? In this particular problem, because we're dealing with probability, where probability is a ratio, does it make sense that no matter how big or small I make this figure, that ratio will always be the same? Right? So let's pick a nicer number to work with. What do you think would be a nicer number to work with? 6, a nice even number, I think would be easier to work with. Okay? So in this problem, I'm trying to find the probability that a point lies in my shaded region. Well, my shaded region is kind of funky. How will I find the area of my shaded region? This is where yesterday's lesson and those homework problems come into play. Zoe, you had to go thinking about it, maybe, I don't know. Absolutely, that's exactly what you have to do in order to find your shaded region. So our strategy is area of the square minus the area of the circle, and that's going to be over, what is the entire region? The square. Okay, so what is the area of the square? 36. Nothing too complicated so far. What is the area of the circle? It's 9 pi. You okay? Okay, so let's take what we found and plug it into this strategy that we had come up with. The area of the square is 36, minus the area of the circle is 9 pi, and I'm putting this over 36. And of course, that reduces. So let's reduce it. Well, let's take this fraction and break it down into two pieces. Let's break it down to 36 over 36 minus 9 pi over 36. Because you can do this with fractions as long as the subtraction is going on up top. If you got subtraction on the bottom, you're not allowed. Okay? This becomes 1 minus pi over 4. And that's the probability of a problem like this, no matter how long the sides are. Because remember, it's always going to reduce. The ratio will always be the same. Now, am I expecting you to memorize that? Gosh, no. But what I'm trying to tell you is if you see a problem like this on a test or an EOC, and the number for the side is like 5 or 1 point, who cares, just make it go away and replace it with an easier number to work with because it's just going to reduce anyway. Yes, ma'am. Remember, if the length of the side is 6, does it make sense that the radius of the circle will be 3, and then we square that radius? Yes, ma'am.
Why did you put it over 36?
Because we're finding the probability that a point will be in the shaded region. Got from this screen what we need? Okay. Your turn is also a Centio question. Once again, I ask that you enter it as a fraction. Yeah, sure. Excellent question was asked. Can I change that 5 to a nicer number to work with? Sure. And I can almost guarantee you, when you get your answer, you're going to look at it and be like, I didn't do all that work. Oh, did I do something? This is, yeah. So did I have to do it one? No. Okay, so you don't have to do it how you did. You don't have to do it how you did. I mean, you can, then if it's the same everything else. But you can think about it, it's 1 minus 1 half. That's you're seeing it. Yes, I do have a daily quiz, and I'll be activating it momentarily. I'm going to stop this question in about 40 seconds. Please make sure you're keying your answer into Okay, the correct answer is 1/2. And as I said, some of you, when you finish doing the calculations and you find your final answer, you might realize, so didn't need to do all that work for that. What's the area of a square? Base times height. What's the area of a triangle? 1/2 base times height. See the 1/2? Okay. So, there is a daily quiz. I will be activating it momentarily.
If you like actually did the problem, then you get this.
Yeah, absolutely. You'll get the same answer.
I did like 1/2 base times height. I used 6.
Uh-huh.
I got
Shh.
18.
Okay?
And then I got for the whole square 36.
Right.
So I did 36 minus 18, which would be 6 over the whole 30.
You ended up in the same place, though.
I got one.
Okay, run that by me again. You got
For the
36 minus 18 all over 36.
So I got 6 over 30.
36 minus 18 is 18, so I would do 18 over 36, which reduces to 1/2. You're good?
Yeah,
Just a momentary lapse. It happens.